From the dawn of humanity, the moon has been a constant companion in our night sky. Its luminous presence, waxing and waning through the celestial sphere, has inspired myths, poetry, and scientific inquiry for millennia. We've come to know its familiar face intimately. The man in the moon, the dark Maria, the prominent craters that tell tales of ancient impacts. But for all its familiarity, the moon harbors a profound mystery, a side of its character that remained hidden from human eyes for almost its entire history. We refer to it colloquially and somewhat inaccurately as the dark side of the moon. This phrase conjures images of perpetual shadow, an enigmatic realm untouched by sunlight. But the truth, as always, is far more complex and infinitely more fascinating. This isn't a place of eternal night. It's a side of our natural satellite that, for centuries, was simply unknown, a frontier of exploration waiting to be unveiled. Today, we embark on a journey beyond the familiar, delving into the extraordinary science and history behind the moon's hidden face. What secrets does it hold? How is it different from the side we see every night? And what does its unique geology tell us about the violent, formative years of our solar system? Join us as we explore the true dark side of the moon, not merely a place of shadow, but a testament to the endless wonders that lie just beyond our direct gaze, a testament to the power of human curiosity pushing the boundaries of the known universe. Our quest for understanding the cosmos often begins right here, in our own celestial backyard. The misunderstanding around the dark side of the moon stems from a simple yet profound astronomical phenomenon, tidal locking. The moon is tidally locked with Earth, meaning its rotation period around its own axis is virtually identical to its orbital period around Earth. This cosmic dance ensures that the same lunar hemisphere always faces our planet. For billions of years, this arrangement kept the far side of the moon perpetually hidden from our view. It wasn't dark in the sense of lacking sunlight. Every part of the moon experiences day and night as it rotates, just as Earth does. The far side simply doesn't face Earth. For astronomers and cartographers, this hidden hemisphere was a monumental blank space, a tantalizing unknown that fueled speculation and ambition. It wasn't until the dawn of the space age that this veil began to lift. On October 7, 1959, humanity finally caught its first glimpse of the moon's far side. The Soviet probe Luna 3, a marvel of early space engineering, orbited the moon and captured 29 grainy, black and white photographs. These images, transmitted back to Earth, were crude by today's standards, but they were revolutionary. They revealed a lunar landscape distinctly different from the one we knew, a heavily cratered terrain, surprisingly lacking in the vast, dark plains, or Maria, that dominate the Earth-facing side. This momentous achievement marked a turning point in lunar exploration, transforming a mythological unknown into a tangible, albeit still mysterious, geographical reality. The far side was no longer just a concept, it was a place, with its own unique features and stories etched into its ancient surface. The images from Luna 3 and subsequent missions like Apollo 8, which orbited the moon with human eyes, confirmed a striking difference. The far side is remarkably different from the near side. While the near side is characterized by expansive, dark basaltic plains known as Maria, remnants of ancient volcanic eruptions that filled immense impact basins, the far side is dominated by a rugged, heavily cratered highlands. There are far fewer Maria on the far side, and those that exist are significantly smaller and shallower. This fundamental asymmetry has puzzled scientists for decades. Why such a stark contrast? The prevailing hypothesis points to a difference in crustal thickness. Seismic data suggests that the far side's crust is considerably thicker, perhaps by as much as 10 to 15 kilometers compared to the near side. A thicker crust would have made it much harder for molten magma from the moon's interior to breach the surface and form Maria, even after massive impacts. But why is the crust thicker on one side? One leading theory, dubbed the Big Whack hypothesis, suggests that a second smaller moon, or a large impactor, collided with the Earth-facing side of the moon early in its history, splattering material onto the far side. Another theory involves Earth's gravitational influence. In the early solar system, while the moon was still cooling, Earth's intense gravitational pull might have drawn material towards the near side, resulting in a thinner crust there, more susceptible to volcanic resurfacing. The far side also hosts the largest and oldest recognized impact basin in the solar system, the South Pole Aitken Basin, a testament to the brutal early bombardment period, offering unique insights into the moon's and indeed the Earth's violent past. Understanding the far side is not merely an academic exercise in lunar geology. It offers unique advantages for cutting-edge space research. Its remoteness from Earth makes it an ideal location for radio astronomy. The thick bulk of the moon acts as a natural shield, blocking out the constant radio interference from Earth's communications, cell phones, and television broadcasts. This radio quiet zone is invaluable for observing faint radio signals from the early universe, allowing scientists to peer back in time to the dark ages of the cosmos, when the first stars and galaxies were forming. Imagine a telescope on the far side, listening to the universe without Earth's chatter. This potential has already been realized to an extent. In 2019, China's Chang'e 4 mission successfully made the first ever soft landing on the far side of the moon, deploying the Yutu-2 rover. This groundbreaking mission conducted geological surveys and, crucially, deployed a low-frequency radio spectrometer, proving the feasibility of radio astronomy from this shielded location. Future missions envision building larger radio telescopes or even arrays on the far side, opening an unprecedented window into the universe's infancy. The moon's dark side, once a symbol of the unknown, has transformed into a beacon for scientific advancement, a silent sentinel that promises to unlock secrets not just of our celestial neighbor, but of the entire cosmos. It reminds us that even in the most familiar places, there are always deeper mysteries to explore, urging humanity to continue its relentless journey of discovery, forever pushing the boundaries of what is known.
Subscribe to the channel and hit the bell icon for more amazing videos.